evening and warm welcome to you all for the Total Smart Talk series Lecture 10, a holistic approach to construction of short panel concrete pavements by Dr. Sridhar Reddy Kasu, Assistant Professor, VCES Telangana. This is the 10th talk series organized by Total Smart Solutions as part of our initiatives to provide a knowledge sharing platform among engineers and academicians through eminent technocrats from academics and industry. We cordially welcome all enthusiasts to the session in the series organized in connotation with Association of Engineers Kerala, Thiruvananthapuram District Committee, Indian Concrete Institute, Thiruvananthapuram District Centre, and high-tech total solution providers about a relevant topic, a holistic approach to construction of short panel concrete pavements by Dr. Sridhar Reddy Kasu, Assistant Professor, VCEH Telangana, who is an eminent academic and also industry expert. The event will feature a panel discussion involving industry experts and academicians. Engineer Rajiv Chatterjee, Engineer Ajit Ramachandran, Engineer Sandeep KG, Engineer Anwar Hussain, and Dr. Vishnu are followed by the presentation. So please stay tuned till the end. On behalf of the organization, Association of Engineers Kerala, I thank you all for joining us today. Association of Engineers Kerala is a non-profit organization of about 4,000 plus engineers from public works, irrigation, and local self-government departments of Government of Kerala. Every year, we conduct technical sessions to update our engineers about new technologies. We also conduct annual sports and cultural meet for serving and retired engineers and their family members. The association encourages research and free discussion on engineering problems we are facing. And we publish periodical containing articles by engineers regarding technical and non-technical subjects. This is our 10th technical session of this year. On behalf of Trivandrum District Committee, I congratulate the organizers, Total Smart Solutions, for conducting this event, and I'm very glad to be a part of this event. I also express our sincere gratitude on behalf of AOEK to the panelists for taking their precious time to share valuable knowledge and experience with our engineers. Now, I request Engineer Anwar Hussain, Chairman ICI, Thiruvananthapuram Center, and Director High-Tech to deliver a few words about ICI and High-Tech.
Thank you. ICI has its headquarters at Chennai and is governed by a panel of selected members from all over India and having a sufficient regional participation. The governing body consists of GC members and chairman and secretary of regional centers. The total membership is now around 16,000 in all India level. In Kerala, we had 3 regional centers, one each at Calicut, Kochi, and Trivandrum. Trivandrum Center includes the KK district of Tamil Nadu also. The total membership in Trivandrum Center is 120. High-Tech is one of its kind retrofitting company with its headquarters at Trivandrum. We are mainly concentrating on structural strengthening, structural retrofitting, and structural rehabilitation works. Now we are on to soil stabilization and foundation strengthening using nanochemicals. Thank you.
Thank you, Anwar sir. Now I request Mr. Jitin Kurian Andrews, Consultant, Total Smart Solutions LLP, and Assistant Professor, Department of Civil Engineering, St. Kitts College of Engineering, to formally introduce and invite a guest speaker.
Good evening, all. Today we have with us Dr. Sridhar Reddy for delivering the session on a holistic approach to construction and design of cast in situ short panel concrete pavement with lean concrete base. Dr. Sridhar Reddy Kasu is an assistant professor in the Department of Civil Engineering, Vardhaman College of Engineering, Hyderabad. He obtained his PhD from the Indian Institute of Technology, Kharagpur, for his work on cast in situ short panel concrete pavement. Dr. Reddy has published more than 10 papers in various reputed international journals and conferences. He has served the engineering community by reviewing different IRC codes for revisions and formulations. He is also serving as a reviewer in top-class journals, namely International Journal of Pavement Engineering, Journal of Multi-Scale Multidisciplinary Modeling, Experiments and Design, Journal of Advanced Composites and Hybrid Materials, Transportation Research Board, Journal of Transportation Research Record, Journal of Traffic and Transportation Engineering, and many more. He's an expert in designing and analyzing payments in Indian, ASHTO, and UK standards. Dr. Reddy has proven expertise in the non-destructive evaluation of payments and numerical modeling of payment systems. His research interests are performance evaluation of payments, response modeling of payments, and multi-scale behavior of concrete and asphalt materials. We are honored to have you with us, sir. Without any further delay, I invite Dr. Sridhar Reddy for leading the session, and I request all the participants to keep muted. And if you have any queries, maybe you can pause in the chat box, or at the end of the panel discussion, we'll take up the questions, or you can ask the questions in person. Over to you, Reddy sir. Thank you.
Many thanks for your kind introduction. Yeah. Before going to the presentation, I would like to thank Turtle Smart Solutions for giving me the platform to present this kind of study, and then Indian Concrete Institute, Association of Engineers Kerala, and then Hive developers. And in addition to them, I would like to thank my parent institute, Indian Institute of Technology, Kharagpur, for giving the platform to work on kind of a new emerging area in the concrete pavements. I would also like to thank my current employer, Vardhaman College of Engineering. Then I'm moving ahead with the presentation. So my talk will be about a holistic approach to construction and design of cast in situ short panel concrete pavement with a lean concrete base. So coming to the introduction, like any other structure, pavement is also a complex structure. It has got various layers in it. So each layer has got a modular ratio. I mean, each layer has got a modulus of elastic modulus with a variety of range of values in thousands, 10,000, and hundreds, thousands, and 10,000s. So when we look at the end of the day, when we look at the modular ratio of each layer, that is going to be drastically changed with each other. And coming to the type of pavement we adopt in India is jointed plain concrete pavement, that is of very common on our highways, in addition to the flexible pavement system. So here that you could see the jointed plain concrete pavement has got a 3.5 meter width, and in order to accommodate the vehicle width, and length will be around 4.5 meters to accommodate the two axles of a given vehicle. And coming to the types of concrete pavements, here we have got a variety of concrete pavements like jointed plain concrete pavement that we typically see on our Indian highways, but we may not be able to see in most of the cases we may not be able to see CRCPs, continuously reinforced concrete pavement system. But slowly people are trying to adopt this CRCP in India also, and new code has come up for CRCP. And there are no specific guidelines from JRCP, jointed reinforced concrete pavement, even in the case of ASTO, because there are a lot of limitations and restrictions on how to design, and a lot of debate on how to design and what kind of performance criteria that needs to be considered for JRCP. So therefore, we do not have much of guidelines from various agencies across the world. Coming to the jointed plain concrete pavement, like any other pavement, it will also suffer from various kinds of distresses. Typically, we design for the transverse cracking not to happen on the highways, and therefore, therefore we have to account the transverse cracking. In addition to that, you may also come across some kinds of cracks like longitudinal cracking, which is along the traffic direction, and there are some cases which may also see corner cracking in terms of durability or decracking. And the moment longitudinal crack occurs, so this portion of this chunk of the slab is going to be longer in span and smaller in the width, so therefore it is highly prone to the transverse cracking. When the transverse cracking and the longitudinal cracking meet each other, the slab is going to shatter into a number of pieces. And another kind of distress is that we typically see on wetlands or wet areas like Kerala and Bengal, Odisha, and all these low volume roads, where we could see kind of a joint faulting on the low volume roads, and we could also see joint open up. And especially this was the picture that has been captured from one of the national highways. And the another kind of distress is mud pumping. We typically observe on the low volume roads where we do not have a strong base and sub-base layers. So therefore, in the case of wetlands, because of the poor subsurface drainage. So there is a quite possibility that there will be a large amount of particles that goes up with the application of traffic loading. In addition to that, we could also see some in exceptional cases, we could also see blow up. We typically see this blow up in cold regions like Jammu and Kashmir and Himachal Pradesh because of the thermal changes in a large extent. So considering those distresses, we only we only bother about the transverse cracking in two ways. One is about bottom-up cracking and the other is about the top-down cracking. Two of them are the transverse cracking only, but they are respective to the temperature gradient that we see. In the daytime, the slab is expected to curl something like this. In the night time, the slab is expected to curl something like this because of the temperature difference from the top fiber to the bottom fiber. So considering those curling movements in the slab, so if we allow the traffic onto it, the moment it loses its support at the mid portion, the moment it loses its support at the edges during the evening hours or late nights, so there could be a possibility for the top down and bottom up cracking scenarios. So as per IRC 58, we consider a philosophy called Minor's approach for the cumulative fatigue damage analysis, where we always seek for the thickness which is safer in terms of cumulative fatigue damage, which must be less than 1, both in the case of bottom-up cracking and top-down cracking. So ideally, when we design the concrete pavement with the IRC 58, we may arrive at 270, 280 in the order of slab thickness, maybe goes up to 320 mm also for our Indian national conditions. So owing to its restrictions and handling that much thicker slabs at distressed locations has become very a typical job and cumbersome job. So therefore, when we look for the alternative, there is alternative called cast in situ short panel concrete pavement. This is how the physical system look like. The whole idea of introducing the short panel concrete pavement is to decentralize the axial loads. It is expected that the slab dimensions that we provide is much lesser than the wheelbase axial wheelbase. And when we look at the profile, it can also have it can have no dowels, no ties in the lateral and longitudinal directions, and it can also have dowel and ties depending on the amount of traffic that we allow onto the highways. So when we go for the thicker pavements, we are bound to use the load transfer devices. But when we go for the thinner pavements, we solely dependent on the load transfer of aggregate interlock. So a kind of shear lock mechanism that happens when the moment all the designated joints crack to a full depth. So all those cracked joints are expected to serve the load transfer through aggregate interlock only. And now when we look at the effect of joint spacing or the structural integrity comparison between short panel concrete pavement and jointed plain concrete pavement, this is how the pressure distribution is going to be. Say for example, in the first case, let us consider the short panel concrete pavement, which has got shorter in dimension, but there is a partial discontinuity on either sides of its slab dimension. Whether it is a 1 meter or 1.5 meter, it depends on you what to choose and how to control the riding quality, and if you have any kind of perceptions on the riding quality. So ideally we go for 1.5 meter and 2 meter. So for a typical case, we have considered 1 meter here. So here we could see that there is a large load distribution to the foundation instead of carrying the load by slab itself. But whereas in the case of jointed plain concrete pavement, the slab is going to take a major role in sharing the load distribution, load transfer and load distribution over a larger area. But here it is less dependent on the foundation. Whereas in the case of short panel concrete pavement, it is more dependent on the base, sub-base and the subgrade characteristics. So therefore, if we speak in terms of technical, right, in the short panel concrete pavement, slabs bend with a little vertical deflection compared to the jointed plain concrete pavement. But that is not the case but that is not the case for jointed plain concrete pavement. And coming to the making of cast in situ short panel concrete pavement, before explaining about the joint making mechanism in the short panel concrete pavement, let me clear about the terminology that we use in our regular day-to-day activities. There are many people, they talk this short panel concrete pavement as short slab pavement, short jointed plain concrete pavement. Like, anyway, all these terminologies are allied to one kind of pavement, that is cast in situ short panel concrete pavement. It is nowhere related to the precast panels. Don't be confused with this short panel concrete pavement. The moment we say short panel means it is a cast in situ short panel only. It is going to absolutely look like a white topping, but it is not a white topping. There is a thin gap between white topping and cast in situ short panel concrete pavement with lean concrete base. Yeah, when we talk about making the saw cuts in the fresh stage of construction, in the initial hours of the concrete placement, maybe after 8 hours to 10 hours, we may have to introduce a first level saw cutting at 3 meter or 4 meter intervals, depending on the ultimate desired slab dimensions. So if we are looking for 1.5 meter panels at the end of the day, we may have to go for 3 meters, so that we can later on in the second level, we can introduce the second cut at 1.5 meters. If you are looking for 1 meter, you can go always in 1 meter multiplied dimensions. Right? This is the first level cutting, and the second level cutting can be made at any day after the concrete pavement construction. Ideally, the first level saw cutting should be done within first 24 hours. But the ideal time window for first level saw cutting is between 8 to 10 hours only. And second level cutting can be made within 1 week of time, maybe 14 days of time. Because concrete has got a tendency that when we look at the volume to area, volume to depth, or area, surface area to depth ratio, it is going to be larger enough. So therefore, it has got a tendency over a period of time. We have, seen with our experience that it has got a tendency that it will crack only at 3 meter or 4 meter or 5 meter intervals, not at the 1 meter or 2 meter intervals. So therefore, the second level cutting can be adopted, and at the end of the day, at the end of the construction, this is how the physical system is going to look like. Once you open to the traffic, again, as seen in the previous case, this is how it looked like. Coming to the global experience on short panel concrete pavement, the first ever construction report that I have found through various databases is the construction report from Michigan Department of Transportation, where they have introduced their short slab construction in 1970s. Thereafter, again, because of some restrictions on saw cutting and the riding quality and people's perception, okay, so they have reluctant to put on these short slabs on their interstate highways. And here the riding quality is better compared to the longer slabs, and we could also see the low transfer efficiency of short joint spacing is much higher than conventionally spaced joints. And then portion of cantilever is assumed to be 0.25 times of its slab length, but it is unknown. We have tried to quantify it. And coming to the drainage, coming to the lateral drainage, subsurface drainage, there was a concern about movement of the very fine particles from base layer and sub-base layer to the top. So therefore, eventually, when it loses its fines at the base layer and sub-base layer, it will also lose the support, and eventually there will be a result in corner cracking. And coming to the accelerated performance testing of short slabs, this was a sponsored study that was carried out in University of Illinois. They have found that corner cracking and longitudinal cracking is predominant on their test track. And coming to the short slab sections, aggressively the Chile have been trying to adopt these short slab concrete pavements in the recent times. They have constructed a lot of short slab sections on their highways. So with their observation, longitudinal cracking is higher than the transverse cracking in the case of short slabs compared to the corner cracking. What I feel is, corner cracking is dependent on how thick you are providing how thick slab you are providing during the construction. If you are providing thinner slabs, they are more prone to curling, so therefore there will be a high chance of corner cracking. If you are providing thicker slabs, then rather having lot of curling, they will result in better performance in terms of corner cracking, and they'll result in either longitudinal cracks or transverse crack. And coming to the summary, based on the slab size, we could able to figure out that based on the USCS experience from the recent article, we could see that 0.6 meters to 1.2 meters slab dimensions are prone to corner cracking. As the slab size increases, whether it is a square slab or rectangular slab, so it is being moved to longitudinal cracking and then transverse cracking. So we are at the large square slabs in IRC 58. So therefore, it is very ideal that to consider the transverse cracking, but that is not the case for short panel concrete pavement. Coming to the research gap, identifying, looking at, global experience. So these are the research lacunae we have identified. There are no stress charts properly developed or available for ready-made design of short panel concrete pavement. There is no performance data, and there is no rational performance data. Performance data is available in whether it is cracking in corner, longitudinal, transverse, that is available, but we do not have any statistical number, and no design methodology or design guidelines is available for cast in situ short panel concrete pavement. And India is going to have a new IRC draft on cast in situ short panel concrete pavement, maybe in a month or two. It is at post processing stage of publication. It has been approved at various levels, so that is going to be published, and it is not given any serial number, so therefore I do not want to disclose that IRC code number. And coming to the construction of short panel concrete pavement on low volume roads, this was done by Professor Pandey, supervision under with the kind help of engineer Rajiv Chitraj. He's the superintendent engineer from West Bengal. So with his kind help, Professor Pandey could able to supervise, and with his innovative idea, he could able to construct a short panel concrete pavement on a block pavement. The existing block pavement was it was permanently deformed all along its wheel paths, and there is a lot of settlement at some locations. And as we typically understand that on our Indian roads, whether it is urban area or rural area, all our roads are being suffered from surface drainage and subsurface drainage. So poor subsurface and surface drainage is there at all levels, at all classifications of the roadways. So prior to the short slabs, this was the condition of the block pavements, and it is a village, and this road is running through a village. It was supposed to be constructed by PMGSY. So initial condition was that, and when Professor Pandey suggested this short panel concrete pavement, so during that time there was not much of technology to make use of good diamond cutters to make the sockets at regular intervals, and it was expensive although, right? So therefore they have made a very traditional way of making the joint sockets by introducing a 3 mm thickness wooden planks. So they have inserted at regular intervals as per the slab dimensions, and it was open to the traffic, and it is absolutely working fine. Personally, I have visited this village road, and we have carried falling weight deflectometer studies on the same road. It was found that good load transfer efficiency was observed. It was higher than 85%. It is well and good, even years of service to the traffic. Coming to the observation at the edges of the pavement, all the sockets that they have introduced with the wooden planks or wooden strips of 3 mm or plyboards, okay, all of those joints are cracked to full depth. So that means what we design for is absolutely solved, or absolutely served its purpose. So this section was around 650 meters, and it will carry heavier loads of sand quarry in that village. And the slab thickness was about 150 mm. And this was the second test section that was done under the supervision of Professor Pandey. But personally, I was there during their construction, and I have tested their materials for the fatigue and all the laboratory characterization. So this is another road which will also carry a sand truck traffic, about 150, 100 and 150 sand trucks are going to move on this road every day. So this was the condition for the existing pavement, where Professor Pandey suggested self-filled concrete pavement way back in 2000s, early 2000s it seems. And by the time it reaches to 2015, 2016, this was the condition of the pavement. There was a large settlement in self-filled pavement. So therefore, they have approached Professor Pandey. We have suggested short panel concrete pavement on it. By making the corrections wherever the larger settlements are there, we have suggested the corrections to make with a lean concrete material. And once it is leveled, we have put in 100 mm slab thickness pavement. And the sockets were made to 1/4 to 1/4 to 1/3 depth. Usually we make to 1/3 depth since it is a low volume road, and it was hard to procure diamond cutters for a local contractor. So we have used handheld cutters to make sockets at every 0.5 meter. Okay, so in the longitudinal direction and in the transverse direction. So this was the finished pavement. And coming to the test sections that we have constructed on national highways, we have constructed two test sections on national highways. One is on NH18, another one is on NH19. The one we have made for NH19, which was a Grand Trunk Road on Panagar bypass, so which we have used for the making of construction report on short panel concrete pavement. Because we do not have any construction practices for the short panel concrete pavement, especially on the highways, although we have got a little experience from the low volume roads. And the second test section was constructed for about 1.5 kilometer on NH18, which runs through Ranchi, Ghatsila, and Chichara, which connects to Chichara of West Bengal and Jharkhand border. So which carries major traffic. Tata Steel factory is there in Ranchi, and Hindustan Copper Limited is there in nearby location. All the truck traffic will carry raw materials through this highway, and this has been used for the performance investigation. So through this, we have we could able to arrive at some preliminary analysis about how to select the slab thickness and how to select the slab, how to select the site, and how and what kind of materials to be selected for the construction purpose. So for the first test section, we have made a single slab model. This has been suggested by Professor Pandey and MV Arunchand of Kerala state, and probably he is working for PWD of Kerala. So through his initial investigation in his MTech work, which has been extended to the preliminary analysis of single slab model, and the same I have extended for identifying the slab thickness for the first test section. So likewise, these are the slab temperature gradients suggested by IRC in various codes, IRC 62 and IRC 58 for various slab thicknesses. And some of the slab thicknesses temperature gradient has been interpolated. And we have adopted a non-linear temperature gradient for critical load conditions of, one is for the corner cracking, another one is for the longitudinal cracking, and third category is for the transfer cracking, owing to its performance reported in literature. Coming to the construction of first test section, which we have done it on a high embankment, which was on a pedestrian underpass, PUP, or vehicle underpass. So which was done it on that. So there was a high embankment as high as 6 to 8 meters high at the mid location. So here we could see around 384 meters of stretch on the NH19 section, where we have varied interface bond conditions, but the slab thickness is remained same. So these are the variables we have considered. But coming to the sub base and the base layers, where we have strengthened them as much as possible from the contractor's perspective and the client's perspective. So to account them, we have used 2.5% of the cement content for the making of cement treated sub-base layer. And for the lean concrete base, that is a dry lean concrete. But for the first of its kind, we have tried a porous DLC layer on this section. So in order to, because in the literature review, we have seen that there is a restriction on the fine content because of number of joints present in the short panel concrete pavement. There's a high chance that the fines are going to move up through these joints. So therefore, we would like to have a restriction on the fine content. So therefore, we have gone for the zero fine concrete, literally, for the lean concrete base. So where we have used around 140 kg per meter cube of cement content, and its grade would come down to around M10 or M12.5, something like that. On top of it, we have carried our construction work with polyester fiber and targeting for the M40 grade. And coming to the construction of second test section, whereas in the case of previously, we have done the construction process in a manual way. Lane by lane construction was happened. There are number of transverse construction joints. There are number of longitudinal construction joints as well. And it has got tie bars and double bars at the construction joints only, not at every joint. It has to be noted. Coming to the test section 2, which we have done it fully with mechanized paver, and whose thicknesses were around 180 millimeters to 220 millimeters. And adjacent to this test section, we IIT Kharagpur have done a proof checking for the same jointed plain concrete pavement. We have arrived at around 260 270 mm. Now you could see that the thicknesses that I have suggested from my preliminary analysis is around 180 mm to 220 mm for the same traffic when compared to the jointed plain concrete pavement. So this is the case, and we have improved this cement treated sub base with a 0.25% cement content extra in addition to the first test section cement content. And it is a fully mechanized construction. It has got a variety of slab dimensions, and there is a two bond conditions. One is with separation membrane and the other one is without separation membrane. And this separation membrane is a geotextile membrane. It is a non-woven geotextile whose thickness would be around 5 mm. Coming to the construction process in stages, the first stage is preparation of the subgrade for the readiness of cement treated subbase. And the cement treated subbase, initially the contract, by the time we have selected the site, it was too late and they have already compacted the subbase layer. So therefore, again, with our supervision and with our suggestions, they have modified this granular subbase, already compacted granular subbase layer with a cement content of 2.75%. We have spreaded the cement bags all along its 1.5 kilometer, and we have cut the cement bags and we have spread over the larger area, and this cement mixing was happened through a plogger machinery. And then DLC was constructed in 2-lane construction because it is a 2-lane highway with a paved shoulder. So its pavement width was around 10 meters, but the lane construction for the DLC is because we have adopted the asphalt paving equipment. Therefore, it has got a longitudinal joint in the DLC. So wherever we have to put the geotextile membrane, we have put it, and then full width paving was happened in one go. Coming to the finishing stage, it is in servicing stage. 2 of the test sections are in servicing stage. The one which is constructed later on, that is test section 2, is performing absolutely fine. It is carrying high truck haul. And here we could see that there is a mention about the slab thickness savage. It is around 50 mm to 90 mm compared to the adjacent jointed plain concrete pavement. Coming to the field evaluation of these test sections. Initially, we have planned for the structural evaluation. Later on, we have tried to evaluate it through functional also, in addition to the structural evaluation. So anyhow, crack width measurements and curling studies were done because there is a lot of gap in the literature. So we would like to understand that. So therefore, we have carried it. So in the first stage, we have carried our FWD investigation, following with deflectometer investigation, to understand the load transfer efficiency between this non-dowelled joints, non-dowelled contraction joints. So since the load transfer is solely dependent on aggregate interlock itself, so we have got a major focus on the load transfer efficiency itself. So this is the physical arrangement of the FWD on real field. And we have compared the two deflections. One is the unloaded slab deflection and the other is the loaded slab deflection. We have tried to calculate the load transfer efficiency. And this load transfer efficiency data is plotted against various seasons ranging from winters to summers, and then ranging the slab dimensions of 1 meter by 1 meter, 1.5 meter by 1.5 meter, 2 meter by 2 meter. All of them are square slabs only, unlike the jointed plain concrete. So here we could see that the load transfer efficiency increases with its age. As I told you earlier, the kind of first level cutting that we have made, the concrete has got a tendency that it will crack at only 3 meters or 4 meters or 5 meters at regular intervals, but not at 1 meter or 2 meter, that whatever the joint spacing that we make. So here, by the time we open the traffic and during its service, the number of contraction joints adjacent to the initial cracked joint is also gets cracked. So therefore, the joint opening at every contraction joint has become very small. So because of the joint opening in small in dimension, there is a large load transfer distribution that was happened. So the load transfer efficiencies were ranging between 65% to 95% for any given slab dimension that we have adopted on our test section. And the second one is we have tried to observe whether there is a correlation between the joint opening at the edges along with its load transfer efficiency. So for that, initially we have identified a crack width measurement, where to measure it, which we do not have any specific guidelines or the test protocols to measure the crack width. So we have used a simple handheld microscope, which we have bought from a local supplier, and it is very cheap enough. It costs around 5,000 rupees. So any one of you can also perform this crack width measurements at your own convenience. And coming to this, we have captured some images, and these images were processed further, and we have measured the crack width through the calibration process, and the average crack width within that image is taken as the crack width, and that crack width is plotted against the load transfer efficiency. And here we could see that there are number of joints that they fall in the second region, and there are some joints they fall in first region. These regions were identified based on long-term pavement performance program threshold of load transfer efficiency for about 85%. And this 0.6 mm of crack width is identified, is marked to be on conservative side. In the literature, they have suggested that around 0.725 mm, but that is not a test protocol, somebody that was carried. And load transfer efficiency, considering the 50%, is a threshold limit specified by IRC 117 for the concrete pavements. So here we could see that large number of joints are performing better, both in terms of load transfer efficiency and the crack width opening. And there are very less number of joints that they are falling into region 2, but still these two regions of the data is falling into the good to fair performance. And coming to the field evaluation of about curling, rather performing in the laboratory, maybe within the campus, most of the people are trying to do it, but this is the real-time data. So we have fabricated our own setup with aluminum frames. So it has got a stud set on either sides, And at mid location, we have fitted a dial gauge to capture the slab deformation with time change or temperature changes. So in addition to this, we have also measured the temperature gradient all along its slab depth also. And this is the curling profile that we typically see. It looks like a sinusoidal wave when we plot this on a timeline diagram. But here, timeline diagram is plotted in a different scale with a slab dimension. So it looks like a sinusoidal wave. And if you look keenly observe at curling data, and there is a delta T temperature gradient along its slab depth, and it has got a maximum slab temperature gradient is at some location at some point of time. After 2 to 3 hours or 4 hours of time, we could see that maximum deflection in the slab curvature. So that means that the slab curvature is not instinct. It is not instant. It is because there is this kind of behavior is attributed to the specific conductivity, thermal conductivity, and specific heat of a concrete material. So this is we have found. In addition to this, we have also seen that higher the slab dimension, higher is the curling magnitude. So from 1 meter to 2 meter slab dimensions, the slab curvature is being increased. The magnitude of curling is being increased, whether it is a bonded pavement or unbonded pavement. Moving on, a lot of people have got a perception. It is not a fair perception about the short panel concrete pavement that too many joints will cause a poor riding quality. It is not so. That is proven with our investigation. See here, you could see we have been trying to compare the different slab dimensions, which accounts the large number of joint spaces according to its slab dimension, in addition to the jointed plain concrete pavement. So here you could see that as per our belief and as per our understanding, that the kind of paving mechanism that you adopt at the construction stage will influence the riding quality a lot, rather these number of contraction joints that we provide on concrete pavements. So here you could see that all our test sections are performing good to fair conditions except at one location. And when you compare these sections with the jointed plain concrete pavement riding quality was even poorer than our short panel concrete pavement. So there, as such, there is no correlation between riding quality and the short panel concrete pavement joints, and this was the case in literature also. Coming to the identification of the critical wheel paths, we have done wheel wandering studies on highways by marking the pavement at 250 millimeters spacing, and according to the slab width and according to the pavement width, according to the number of lanes that you adopt on the highway, these critical paths are going to be changed accordingly. When you are trying to adopt the slab dimension, you must choose. Okay, so as a part of this study on 1 meter slabs and 2 meter and 1.5 meter slabs, we have tried to identify the critical path location for variety of slab dimensions. So through this, we have identified some critical load positions that I'll explain you later on in the coming slides. Thereafter, whatever the data we have collected from the falling weight deflectometer, that has been tried to simulate with Abacus software by modeling the pavement system. And this pavement system has been tried to back calculate all its properties and boundary conditions along, or they should be in line with the real-time conditions. So similarly, number of slabs were considered for the finite element model also to consider the boundary conditions effect. And there is an extended base every time. If you see in real-time pavement construction also, the base and sub-base layers are going to be extended in nature. They are not going to be sharp drop down all along with its slab dimension or slab or pavement width. So therefore, extended base is considered to avoid unnecessary complications in modeling. And these joints were modeled with the translated springs, and we have applied a similar kind of falling weight deflectometer loading on one kind of slab, and then we have tried to observe the deflection ball. And these deflection balls were compared with the field deflection balls that we have obtained from FWD. So when they are, when they are in better match with the root mean square error, in terms of root mean square error, we have identified that our model is calibrated. Further, that model is used for developing the stress charts to calculate the stresses basically. So to calculate the stresses for a variety of conditions, different temperature gradients as per IRC 58 was considered. One is at the maximum temperature gradient, another is at the lower side, and we have considered the axial load magnitudes in line with the Nash Highway system. These are the critical load positions that we have identified through wheel load distribution. So it has seen that corner loading and as I have told you in the previous cases, longitudinal cracking, and here it is a bottom-up longitudinal cracking and then bottom-up transverse cracking. So what is new here is the kind of longitudinal crack that we have to consider for design of short panel concrete pavement is bottom-up longitudinal cracking rather top-down longitudinal cracking. But when it comes to the when it comes to the transverse cracking, it is both top-down and bottom-up. So these are the stress charts that we have developed for a variety of conditions. Probably, you could see these stress charts in upcoming IRC code. Here, this is for a specific case for a variety of, loading conditions. Similarly, for another temperature zones, these are the stress charts. And for a top-down transverse cracking, this is the loading position. Considering the rear axial spacing as 1.3 or 1.4 meters, this is the case applicable for only 1.5 meter and 2 meter spacing, not for the 1 meter spacing. For the 1 meter spacing, we have to consider the corner cracking and then bottom-up longitudinal cracking, bottom-up transverse cracking only. These are some of the stress charts that we have developed for various temperature gradients. So through these, stress charts, we have developed equations, regression equations for computing the stresses, and these equations are very flexible and easy to use. These are very similar to IRC 58 equations, and in a way we can also describe that these regression equations are in line with the Westergaard equations. They look absolutely similar to the Westergaard equations. And these regression, of course, these regression equations have got their own set of limitations. Depending on the availability of the data, we have presented the equations here. And coming to the illustrative example that we have presented from our study is considering the axial load spectrum that we have initially adopted for H18, and for the same design traffic, JPCP was around 270 mm, and these are the model parameters to compute the stresses and stress ratios. Further, we have computed the fatigue load repetitions. So this is how the stress spreadsheet that we have prepared in line with the IRC 58. So for cumulative fatigue damage analysis for top-down corner cracking, we have accounted all single axles, tandem axles, stratum axles as single axles. We have converted all of them into single axles. For the longitudinal bottom-up case, the same thing is adopted. For the the transverse bottom-up cracking case, we have adopted in the similar fashion. But coming to the top-down transverse cracking, we have accounted only rear axles and tandem axles to compute the stress ratios, and then further allowable number of load repetitions to compute the fatigue life consumed. So at the end of the study, we have also given an illustrative example with a neat tabulated form to observe whether our assumed slab thickness in the test sections is safe or not. So when we stipulate the slab dimensions and then slab thicknesses in line with axial load spectrum, we have seen that whatever the thicknesses that we have verified, all of them are being satisfied with the, in terms of cumulative fatigue damage, are being satisfied with the the geometries that we have adopted in the field. And here one has to note down that this short panel concrete pavement is, in terms of cost of construction, it is almost all equivalent to bituminous pavement. And but there will be a performance on the other side. So we have to look at, when we try to adopt a type of pavement, we have to look at its life cycle cost analysis and its initial cost of construction also, and they should be compared with the performance. And I must thank my love and my hero is Professor Pandey, because of his selection of the topic for my PhD research. He is my trust, he is my force to carry this research. I must be thankful to him. Big thanks to him. And I must also thankful to contractors or concessionaires, who allowed me to construct my own kind of recipe on their highway. And it was sponsored by National Highway Authority of India. I must be thankful to them. It is a sponsored research. Yeah, thank you all.
That was a wonderful presentation from Sridhar sir. Now we can start the panel discussion. I invite the moderator of the discussion, Engineer Ajit Kumar GS, an eminent practicing engineer who has more than 30 years of experience in the construction field and depth positions like Project Director, Project Management Unit, Review Kerala Initiative, Superintending Engineer PNGSY, Superintending Engineer Thiruvananthapuram Corporation, and now he is Chief Technical Consultant of Further Translations. Now over to you, Ajit sir.
Thank you. Good evening, all. Thank you, Sridhar Reddy sir. We had a wonderful presentation on a relevant topic. We can now start the panel discussion. I will first introduce all the panel members. Firstly,
Thank you, Sridhar sir. You are the one of the wonderful person. You are a great person. Super. IIT Kharagpur. You are the super person.
Thank you.
First engineer Sri Rajib Chatraj sir, Chief Engineer PWD West Bengal, has pioneered in the execution of SPC in India. He has a published paper on design of SPC pavement way back in 2010. Kerala has started construction of SPC in 2020 through Rebuild Kerala initiative. We have taken his advice and he was mindful to advise us proactively. Sri Chatraj sir graduated from REC Durgapur, now NIT Durgapur, in 1986 and joined PWD Government of West Bengal in 1991. He has more than 3 decades of professional experience in building public assets like buildings, bridges, culverts, and highways, and presently serving as Chief Engineer, National Highway Wing, Public Works, Roads Directorate, Government of West Bengal. He has served the Indian Road Congress in the Committee of New Material and New Technology Accreditation. He is now member of several technical committees of IRC. He served as Superintending Engineer of many NH projects, among which NH60A, Bangura Perulia NH, and high-level bridge over river Catania Doania on NH117, had won Excellency Award of Ministry of Road Transport and Highways, Government of India. He took part in academics and research works related to pavement engineering. He has, in his credit, several published papers in Indian Road Congress journals and also in international journals of road material and pavement design of Francis and Taylor. Welcome you, sir, to the panel discussion.
Thank you very much. I think I'm audible.
Yes, sir. Yes, sir. Yes, sir.
First of all, I beg apology because of some problem of the Wi-Fi connection in my home. I am attending this webinar through my mobile only. So
Okay,
there
sir.
may be some disturbances and something. And
Okay,
after that, thanks to the organizer, Tatal, and for taking the initiative for introducing such a very innovative technology. And thanks to very beloved Dr. Sridhar and Dr. Vishnu. Both of them are the doctoral scholar from IIT Kharagpur. With them, I was actually acquainted from their research days, PhD days. And I was also very fortunate to be very closely associated with Dr. B.V. Pandey, none other than the father of pavement engineering in our country, we call. So actually, the story it was started. Sridhar has actually Dr. Sridhar has presented in his presentation and shown some pictures from that was probably the first. Though it may be a small project, but it was the first of its kind of the short slab, or that time we call it short parallel concrete pavement. Now the code is, I'd say, code is going to come. They're calling short slab concrete pavement, whatever. It started. The story was started when I just in 2011. I just I went for attending one workshop in the US for something like that in IIT Kharagpur. The very dilapidated road condition that was shown by Dr. Sridhar, that was there in my mobile. I have shown that to Professor Pandey. Then I just interacted with him. What is the way out? So he suggested, can you do something out of the box? So I have told him, well, I'm ready. I have to take the permission of my higher authorities. But with this condition of the traffic, one correction that Dr. Sridhar has told, that is not actually a PMGSY road. That is a part of the state highway that was carrying a lot of heavy traffics. But in that portion, 650 meters, so
I'm
it
sorry.
was very closely means drainage was blocked. It is on the both the sides. There were heavy encroachments or something like that. Habitations were there, and there was no way out for the drainage at all. So every rainy season, it was a big headache for us. So naturally, when Professor Pandey has told me you have to think out of box and do something new, I was instantly ready to do that. And things started with this. The journey was started, and after a lot of obstruction that was faced from my very old mindset colleagues, like the estimators in my higher office. At that time, I was executive engineer. So in the estimating section of the superintending engineer, I faced a lot of obstruction. And during the time of the construction, also people has wrote many complaint letter to the chief minister even of the state. He is wasting the government money like that, and our seniors also discouraged me like that means you are going, your service is going to, you are not be spared, you will be in soup like that. Lot of negative this thing was there, but Professor Pandey was there. He was behind every day. I was just executing the things, and I was just sending him. At that time, this WhatsApp was not so popular, so I was just mailing him and getting his advice every day, and just constructing. And also, Dr. Sridhar, what he has told that with the this giant paneling. Shock cutting, it was started with putting the 3 millimeter thickness of the ply. It was, but it didn't work actually. But what we adopted, that is hand operated marble cutting machines that we have adopted. And finally, the picture that Dr. Sridhar has shown, that the cracks is propagated up to the end. That was the intention actually, and that was the beauty of the technology. I think also one point to be mentioned from the has to be mentioned from the workmanship point of view. That is, you have to. There is a specific time window that is very important for the shock cutting. So 8 to 10 hours after the this PQC was laid, the shock cutting within that window, time window, that is very, very important. And also what I feel, that is the means total, it is actually since it is much lesser thickness than the conventional JPCP that we adopt, that is around 300 or 300 millimeter plus thickness we adopt for the JPCP. Here it is, we have done it PQC there 150 millimeter. There is a specific this thing, but the code is going to be published. It is almost on the final ship. Today also Professor Amarnath Reddy has presented in another webinar. So I'm also council member. It has been presented of the IRC, and it has been presented in the last midterm council meeting in Raipur IRC. And now in Gandhinagar is going to come up on December. It's going to be published. That I had a talk with Professor Amarnath Reddy sir and Joga Rao, and that time Sridhar was the two researcher was doing the research on this topic. The Mankar project was a very humble step, as a small step, but towards a very promising technology that can replace the total this JPCP. And it is also pertinent to say here that so far I also know this technology is not tried in any other countries. Maybe somewhere in Chile it has been tried, not even in US, not even in Europe it has been tried. And if it is, I'm sure there are some issues, some delicacies in there. Concrete itself is a very delicate material compared to the bituminous work. There are some delicacies in the bituminous construction too, like maintaining of the temperature and all the thing. But what I feel with my experience, whatever I have, that concrete is much more delicate material to handle, and especially the kind of the structure in form of the pavement, where the surface area is much more than the means compared to the volume of the concrete. There the plastic shrinkage crack occurs very often, and that is a killer. We all know that that is a killer. And this time window of the shock cutting, that is very important for adopting this technology, and you have to be very, very careful while executing this technology. I remember in 650 meter of the length of this pavement, what we have done way back in 2012, in the month of March and April, we have completed. And so far, it is performing very nice. And after seeing this success of this this short stretch of road, along with his disciple, Professor Pandey was very excited to approach NHI for the test section. And both the test section, as Dr. Sridhar Kasu has mentioned, in Panagar bypass, that is NH19 and NH18 in Jharkhand. Both the test sections I have visited. Actually, in Panagar, it was a bit means earlier of these two case studies, test sections. That was some construction issue was there, and a portion of that short panel concrete pavement was dilapidated after construction of 2 years or so. And after that, when investigated, it was found that the concrete strength of the PQC layer, it was found 23 MPa or something like that, if I correctly remember. So there were a lot of construction issues there. So, but this Jharkhand test section was much better. But what I have also visited along with K. Sir, Professor K. Reddy and Joga Rao, the other researcher on this topic. There also I have found some slab panels were very disintegrated, has come out. There were corner cracks and some other cracks are there. And wherever I have found that, and there was actually some detachment with the base layer. So it is also very important to have a very sound base and for the bondage. And whatever the code is coming there, actually it is the thickness has been much reduced than conventional JPCP, but still we can further reduce if we can further work on the bondage with this base layer. Like it may be DLC, it may be CTB, or what we have done there, we had done there. That was PCC, as because at that time in a very means away from around 50 kilometers away from a district town, So at that spot, it was very difficult to arrange for the CPB and all the things. And so, the ready-mix concrete was available. So we went for this PCC. So further research areas are left for further reducing the thickness of this thing. If we can improve the bondage between the base and the PQC. Here only the cost reduction is not the factor, not only the factor. Here the environment is a very, very big aspect. We can achieve a lot of carbon credits if we adopt, and it has, this technology has got the potential to replace the JPCP. So if we can adopt, the India can emerge as a country where this technology can on lot of carbon credits, environmental issues will be taken care of. And in this technology, not only the concrete volume will be reduced, almost there are reduction almost to nil or 10% or 5 to 10%, we can say, the uses of the towel bursts. That is also one very, very important improvement from the conventional technology. That is all. Thank you all. Thank you. Special thanks to Dr. Sridhar.
Thank you, sir. Thank you, sir. Sir, I have one doubt. You told us, you shared us all the problems, advantages of the SPC concrete. You started the SPC concrete very earlier. So, what is the contractor's response in this new technology, sir?
Contractor's response was, we have actually, fortunately, we could reserve this for the engineers cooperative, this thing means this work. That was in way back in 2011, it was tendered. It was around 50 lakh, the budgetary estimate was there. And the engineers cooperative who has been awarded for this, they took the interest. They took all the means, whatever, it was a strutting. So for the jointing, shock cutting and all the thing, whatever we have told after getting the advices from Professor Pandey, but whatever we have told, we started with, as in the photo also you have seen, started with the 3 millimeter plank. And after that, we have adopted this shock cutting with a marble cutting, hand operated marble cutting machine. So they have abided by all the things, and that is reflected on the road. So it is performing very, very nice, very nice.
Okay,
Still.
sir. Okay, thank you, sir. Thank you for sharing a very good experience, sir. Thank you, sir.
Thank you very much.
Next, we have Engineer Sri Ajit Ramachandran, Chief Engineer, Kerala PWD. Has an excellent track record on modernizing PWD and leading the organization in execution of a number of remarkable works. Welcome you, sir, to the panel discussion. Is Ajit Ramachandran sir is available? I think Ajit Ramachandran sir is an official tour. Sir is on the way of traveling. I don't know whether he is present. I think Ajit Ramachandran sir could not attend. Okay. Shall I proceed?
Yes, sir, please.
Okay. Next, to introduce Engineer Sri Sandeep sir, the Chief Engineer of LID and EW Department, an engineer with a vision who leads an engineering wing of local self-government institutions in Kerala with around more than 4,000 engineering staff. He has vast experience in the construction of PMGSI projects, which makes him now the most suited leader of the organization. Welcome you, sir.
Thank you, moderator, for a wonderful introduction. And the presentation was especially by the Dr. Sridhar, sir, and it was wonderful. And this really relating to our rural roads. Okay. And Rajib Chatterjee, sir, Chief Engineer, PWD West Bengal. Sir has also shared his experience with the starting of the short panel concreting. Because always there will be a reluctance when a new technology or a out of box thinking is there. So it is already happened with that. And after 2018 and 19 floods, Kerala also started with the restoration of the roads which are damaged due to the floods. And considering the life cycle cost and the high durability, with the help of Vishnu sir and all, in Rebuild Kerala, we could able to complete 48 kilometer short panel concreting, and it is almost nearing completion that kilometer, and which is in the evaluation, and which is performing well in Kerala, and it is very best and suitable for the Kerala condition, considering the soil, where the soil conditions are better. And also, I would like to clarify whether we can go for with just a GSB layer and with a 100 mm short panel concreting, because we have already done that, because we are not using the lean mix concreting in this. So somebody has also raised the question that whether we can go for lean mix concreting in the gradient road where we are not able to compact properly. So I think Dr. Sridhar sir will be answering that question. And as far as PMGSY is concerned, we are also proposed a 45 kilometer all over Kerala with short panel concreting as a new technology, and which is already approved by the NREDA, and which will be completed within 1 or 2 years. So comparing the cost in a manual, a conventional bituminous road, it is coming almost 43 lakhs per kilometer. And when it is a panel, short panel concreting with 10 centimeter concrete and 10 centimeter GSP, we are getting 45 lakh per kilometer. So almost the cost is 5 to 10% variation, but the life cycle cost is comparatively better in this short panel concreting. So we are observing that the short panel concreting is best suited for the rural roads concerned. So I would like to hear from more about that, whether we will be able to go with that GSP plus short panel concrete of 10 centimeter thick in rural roads also. And anyway, we are completed that 48 kilometer, and some roads are already completed 1 year, and we are already in the evaluation. And we would like to get more advice from the panel, Reddy sir, and also the Chief Engineer West Bengal, and also Vishnu sir, whether it will be possible for our other rural roads also. Because the only thing, the difficulty we are faced is the curing period that we have to block the traffic in that road, and sometimes we will not be able to do that curing properly. And sometime immediately after the concreting and all, the public will be using their vehicles to cross this road and all. So that type of difficulty we are facing, and the contractors are also reluctant, because only a less thickness of concrete is consumed in this. So that type of issues we are facing. So suggestions for overcoming these type of difficulties we are also expecting from Sridhar sir. Thank you.
Thank you, sir. Thank you, sir. Next.
Thank you. Thank you.
Next, I have to introduce Engineer Sri Anwar Hussain sir, who is the director of the firm High-Tech Total Solution Providers and chairman of ICI Thiruvananthapuram Center. Anwar Hussain sir was former deputy chief engineer of local self-government department. He is now practicing civil engineer with expertise in soil improvement techniques and green construction methods. Welcome you, sir.
Thank you, Ajit.
Sir,
Yeah.
you are always on early adopter of new technologies, and you are the advisor of many government projects related to low volume roads. What is your vision on the adoption of this technology on low volume roads in Kerala?
Actually, this is a very wonderful proposal and presentation. Thank you, Dr. Sridhar Reddy, for this presentation of short slab concrete. And I'm limiting my talk to one question only because due to paucity of time, and actually due to some connection problems, I missed something here and there. What I want to know is this: how appropriate load transfer between adjacent slabs are ensured for long-lasting payments without curling or settlement due to differential stresses between the panels or below the panels at the time of load transfer. This is one thing because there are a lot of panels there, and the junctions may be critical, I think, and I request an answer for, answer of this. Thank you.
Thank you, sir. Thank you, sir. Now, I would like to introduce Sri Dr. Vishnu sir, our Assistant Professor, NIT Warangal. He is a blooming transportation expert with an immense of research and field expertise. I was fortunate enough to invite him to the Technical Committee of Rebuild Kerala initiative way back in 2019. He accepted it, and he has proposed a lot of resilient technologies for the project. SPC is one among them. He can be proud that the project management unit of Rebuild Kerala initiative has completed many kilometers of roads using SPC in flood-prone areas till now under his mentorship. Welcome you, sir.
Yeah, thank you, sir. Thank you, sir.
Sir, when you proposed the SGC technology to the project management unit of Rebuild Kerala initiative, there were no precedents, no construction histories in Kerala. What has given you in the confidence to do the proposal to a larger scale?
Sir, confidence is something which I believe it comes over time. So I have been quite fortunate, as what Sridhar was also referring. I was been quite fortunate to work under Professor B.B. Pandey, and we had like during our academic time period over there. So sir was explaining several success stories which he was able to do in West Bengal. So and also one of my senior who happens to work in LSCD now. So he has worked with Professor Pandey, Arun Chand. So he has worked with Professor Pandey, and I have come across his paper which was published in Indian Road Congress. So to one of the questions which was asked by Sandeep sir, in most of the roads which are designed for short panel concrete, we have not considered temperature stresses. So we had only considered load induced stresses, which was considered in the IRC paper, which was given by Arun Chand and Professor Pandey. And my confidence was basically based on the confidence which I received from Professor Pandey. And definitely when we look into this technology results in reduction of pavement thickness, especially your concrete thicknesses, which will result in huge savings. So for a rural road, rather than going for conventional 150 mm thickness, which is a minimum recommended as per IRCSP 62, rather than going for that, let us actually reduce the thickness. So this was the thought. So again, I knew Sridhar while we were doing PhD together. So with some guidance from all of us, from all of my fellow colleagues, I thought let us work. I have a couple of queries, not queries. I have some clarifications from Sridhar. It was very interesting to see that your load transfer efficiency, which you evaluated, was increasing with respect to time. I was expecting that as the crack tends to proceed down, the load transfer, of course, even if it is with aggregate interlocking, how would it increase over time? This is one thing. This is one concern. And again, the second concern is when you're using falling wave deflectometer, and that too when you have geophones placed at up to 1200 millimeters, how does the discontinuity in a short panel concrete slab affects the deflection readings? So these two concerns are there. Over to you, Sridhar.
Sir, shall I take up the questions?
Okay, thank you, sir. Okay, sir. Continue.
Yeah. So let me share the presentation once again for the better clarity. What I would like to highlight is here when we make the saw cutting. So the concrete has got a tendency that it will crack only in the initial periods. It will crack at 3 meters only, or 4 meters or 5 meters. Okay. So here, for example, in some cases, if you look at the profile diagram of this one, okay, some of the joints are cracked, some of the joints are not cracked to full depth. Okay, and eventually these contraction joints will also crack. Okay, over a period of time. So in the initial time when we have investigated with FWD, this is a cracked joint, and the adjacent to it is not a cracked joint. So therefore, the joint opening must have been higher in the initial days, and over a period of time when the adjacent joints are being cracked, so the joint opening at this location is going to be smaller compared to the initial joint opening of the same joint. So that was the case that led to increase in load transfer efficiency. Probably probably Dr. Vishnu must have got an idea about it. Okay, and the second question was about when we place the falling wave deflectometer on this short panel concrete pavement. Usually, it is expected that the geophones are going to spread over a larger area. Okay, so when they spread on the larger area, say for example, the first geophone is likely to have on one slab, loaded slab, and the second, third, maybe 4, 5, 4 in 5 serial number geophones may be falling on the second slab, and the last 1 or 2 geophones may likely to fall on the third slab from the loaded slab. Okay, so in such a case, yes, there is a hindrance in the deflection ball, and there we could see that a kind of magnitude of drop in the last geophones compared to the geophones falling on the second slab. Yeah, this was observed. But the geophones that are much away from the loading plate were having very negligible deformations in some times. These are the 2 answers from my side, and yeah.
Thank you, Sridhar. I think one more clarification was regarding how was your load transfer efficiency was found to improve. Sridhar, you're there?
Yes.
It was
So
interesting to see that with respect to time, your load transfer efficiency was found to increase, was found to improve.
Yes.
How do you justify it?
Yeah, this is not in my study itself. This was the case with the one of the Canadian study also. They have gone for inlays of concrete pavement. So they have observed the similar kind of observation, but they did not make any statements or conclusions on it. But as per my observations, as I told you earlier, say for example, if you look at my cursor, okay, so the contraction joints that we have made in the initial days, it was cracked, but adjacent contraction joint, maybe at 1 meter or 2 meter or 1.5 meter interval, they must have not cracked during our testing in the initial period. But when we allow the traffic onto it, because of the thermal changes and because of the load applications, the adjacent joints were also cracked to full depth. So therefore, the joint opening of the same joint is going to be varied over a period of time with its age. Since the joint opening is smaller and smaller with the age, So the load transfer is being likely to increase. So this was my explanation, and these are the things come into my observation.
Okay. See, I think Sandeep sir has also told the fact that whatever short panel concrete pavements that we used, it is actually designed considering only wheel load stresses. And when I was actually going through the equations, what you have proposed for stress computation, the temperature induced stresses are found to be, I mean, the coefficients are found to be very small. So, with respect to the wheel load stresses, what was your temperature stresses in terms of percentage?
They are around 20%, not even higher than that.
Okay, okay.
So around 10 to 20% that we have seen. Yeah.
Okay.
So if you see the coefficients, with delta T, they're very small.
These are very small. These are very small.
Yeah.
So as of now, the sections whatever we have designed in Kerala, the 48 kilometers, what we are talking about, this has been designed only by considering wheel load stresses.
Yeah. So in order to complement that, I would like to give a point. I would like to add explanation to Sandeep sir and yourself. When it comes to the low volume roads, it is expected that they are constructed in vegetation area, and then they are running through maybe in urban areas. So it is high chance that the temperature gradient that you see in it, okay, even if you measure it also, okay, so they are going to be much smaller when we compare these roads laid in a open area. Okay, so because of these buildings and presence of the vegetation in and around, so the temperature gradients are going to be much smaller compared to the open area road.
Okay.
And in addition to that, I would like to add another point. The lands, like in Kerala especially, they are wetlands and marshy lands. Okay, so the temperature gradient, humidity is going to be higher. So and the kind of moisture presence in maybe on either sides of the highway is going to be higher. Water table is very close to the maybe embankment or the subgrade also.
Mm-hmm.
So because of that, the temperature gradients are going to be smaller.
It
is nothing wrong in considering only wheel loads. Yeah.
Okay. Thank you, Sridhar.
And in addition to, this is the answer to Jiju sir. In Kerala, rigid pavement is proposed for lanes and low volume roads having high gradient. Sir, I think I understand your concern. For high gradients also, we can adopt this short panel concrete pavement unless until you have very high embankment or very high filling. Width of roads are restricted. This mix of base and base compaction most impossible. So this compaction should be in line with the MORTH specifications, MORTH 5th revision. If you are using a static roller, you may have to lay the lift thickness or the material thickness or layer thickness about 150 thickness for the subgrade and subbase layers. If you are using a dynamic roller, a kind of vibratory compaction, then your lift can be as high as 200 or 250 in terms of construction. So
possibly
rolling may not be
with respect to his question may be related to placing of concrete also, because on high gradients, while the concrete is in plastic state, this can flow.
Yeah. So
that can also be a concern.
Yeah. So there are a lot of concerns about concrete pavement construction when building construction engineers come into the picture. Okay, they think that it is a kind of building grade concrete. We have been keep on stressing the word called paving grade quality concrete, PQC. PQC is completely different from the concrete that we use for the building construction, where its consistency is going to be very, better, and it will be having very low workability, low slump value. But whereas in the case of building construction, their slump value is higher. So in the case of concrete pavement construction, since the workability or the slump value is lower, okay, there may not be a probability of flowability, or once you place it, you don't need to worry about how much it is going to spread, or how much it is going to slip or slide after the concrete placement. So this has to be noted, even for the PWD engineers also. When we assign the engineers, okay, they should have a background of road construction experience, not the building construction experience. It is a complete misconception that a building construction engineer can work on road construction activities, because their concrete mixture consistency and its viscosity is completely different compared to the PQC. And the other question is, can we use lean concrete mixture of grade 1:4:8 as base layer for the base only with SPC for these particular cases, as rigid cover will be the only solution? Yes, you can use lean concrete mixture. And in addition to your doubt or your query, I would also like to mention that where the water table is high and as close as to subgrade or the embankment, so you can also use the cement content in granular subbase layer, plus geotextiles also can be used. I think Dr. Vishnu must have suggested, Rebuild Kerala initiative should use geosynthetics or geotextiles in a large extent on their low volume roads. But in addition to that, my point is you can also make use of the cement content for the subbase layer, where the drainage is a problem, where there is a problem of soil erosion also.
Dr. Sridhar, there is also a question asked by Chief Engineer Sir of PMGSY of Kerala. He has asked, can he build for low volume roads on GSP PQC, construction of PQC over GSP? Can this option for the low volume road for the short panel concrete pavement is possible? To my idea, I think the answer after that, you will just take up this question and clarify further. This base should be non-erodible. That is a very pertinent point to be addressed, because
Yes.
because of any water percolation or something like that, the base should not be softened like that. So here the compressive stress is much more than the conventional JPCP. So here the base should be non-erodible in any form. Now you may take up this question and further clarify.
Yes, sir. Directly on GSB may not be a good idea, because GSB will have fine content in it, and it is likely that it is supposed to serve for the subsurface drainage also. So when you use the short panel on the GSB directly, these fines or maybe whatever the moisture that is going to be available in GSB, it may come up and it may lead to mud pumping, a kind of mud pumping, not exactly a mud, not exactly a mud pumping, a kind of mud pumping may occur at these contraction joints. In addition to that, you can also propose WBM for about 150 mm or 100 mm. Provided if you have got an opportunity to alter the gradation for the WBM proposed by MORTH specifications, ensuring that the fine content is less than 5%. And I believe all our MORTH specifications and IRC specifications have judiciously made to counter this kind of issues. And there are some gradations that are directly borrowed from various agencies' guidelines. Yes, sir. I see another question from Shiju Chandran, sir. How to choose the slab thickness and slab sizes for low volume roads? Sir, the slab size is dependent on how much lane width you are going for and what kind of truck traffic that is going to come on it. Coming to the slab thickness again, it is dependent on the slab size only. You do not have any other way to directly choose a slab thickness. So for a given slab size, you can for a given slab thickness, you can go for a variety of slab dimensions. But for a given slab size, you cannot go for a variety of slab thicknesses. And I could see another question from Rifin Kijan. Cracks are seen at the corner of the starting panel at the junction between a plain BC road and SPC road running through a higher gradient how can we prevent that? Yes, this was the, sir, in my experience, I have seen such kind of cracks. Probably these things can prevent when we have, a concrete kind of barrier between, rather a smooth transition. You can always have a, kind of confinement that we provide in block pavements. So therefore we will not be allowing any kind of movement in the bituminous material, any kind of movement in concrete slabs also. So through that we can avoid a kind of cracks that coming from that comes from a junction. Another question: within what times cutting has to be completed? Cutting seems to be time consuming. Sir, for your kind information, I would like to highlight that here the saw cutting that we adopt in short panel concrete pavement should be at the two-level saw cutting, two-level, but it is at a single location. It is going to be a single cut. But when we go for the jointed plain concrete pavement, everywhere in order to fill and seal the joints, we have to go for the secondary cutting also. That secondary cutting, rather having the secondary cut in the JPCP, if you could able to adopt the SPCP, that secondary cut can make as another adjacent first level cutting in the short panel concrete pavement. So in a way, it is not a cost concern, but when it comes to the time consuming, yeah, more or less it will be of the same time for the construction and making the saw cuts. Any other questions?
If the participants have any further questions, you can unmute and quickly ask one or two questions. I think there are no further questions. If there's any more question, we'll surely forward that to Sridhar sir, and probably you can answer to that.
Jitin, one request which I want to make to the LSDD chief engineer is that please provide us some facility so that we could evaluate the sections which were constructed using short panel concrete. Or people who are in RKI, they should also look into evaluating the new technology what they have constructed. Rather, the focus is mostly on constructing. No evaluations have been carried out. So each of these new technologies that have been constructed, these would actually give us very valuable data which would help in revising many codes, specifications, etc. So people who all are associated with RKI, see in whatever means they could help us in collecting field data. Thank you.
Sure, sir. Sure, Vishnu sir, I'm here. We are always with you, and we need your support because we are not having the sufficient the testing equipments with us, and we are seeking the help of engineering colleges. But I think you can help us
Definitely. We all
because you were there with the RK in the earlier periods.
Yeah.
So we need the evaluation to be done at the earliest because we are already completed the target of RK, and also in PMGSY also we require your support.
100%.
So please
We'll
give us a proposal so that we can.
Thank you.
Thank you, sir. We are so happy that we are having very good discussions at the end, and some productive output would be there. I'm actually representing an institution which is supporting or in association with Rebuild Kerala, and on behalf of the institution, I also agree that we will be truly happy if we can collaborate in performance evaluation of these roads. And if there are no further questions, we'll find the sections. So once again, thank you, Sridhar sir, and all the panel members for your valuable time, and also all the participants for your patient listening. Thank you all. Good night.